Honorable Speaker, ladies and gentlemen, I, Miss Manasi Chaudhary, lecturer in mathematics, uh, on the behalf of organizers, I extending a heartfelt welcome to you all to the national 3 days national webinar, Sri Jagannath Memorial National Webinar on the importance of mathematics and science in 21st century. This webinar is initiated by Department of Mathematics with close collaboration with Adivasi Research and Development card, Odisha. I feel happy to express a brief introduction about our today's speaker. Our today's speaker is Dr. Parthasarathi Mukhopadhyay, sir, Associate Professor, Department of Mathematics, Radhakrishna Mission Residential College. He is a gold medalist in MSc uh, in pure mathematics CU and also secured MPhil and PhD in pure mathematics from the same university. He is the corresponding editor of Bhavna, the mathematical magazine. He has also co-authored books like Topics in Abstract Algebra, Rudiments of Mathematics, Prarambhik Ganit in Bengali. He has edited books like Linear Algebra Theory and Applications. He has various web lectures in YouTube, including national and international webinars. He has addressed and attended numerous international conferences in India as well as in abroad. Uh, Apart from that, he has published popular articles and research paper on mathematics. Sir, I welcome you from my core of heart. Sir, your topic is as you suggested you suggested importance of mathematics in 21st century. Uh, Special reference to evolution of zero. Now I would like to stop here and invite Dr. Parthasarathi Mukhopadhyay sir to initiate his talk. Over to you, sir. Thank you.
Thank you very much. Thank you for the kind introduction and a very good morning to everybody. Allow me to present my slide. And while these technical things are on, let me take this opportunity to thank you again from the core of my heart for giving me this opportunity to share my thoughts with you on this very prestigious occasion. We are celebrating an extended celebration of National Mathematics Day. 22nd was Ramanujan's birthday, and this is his 100th year of sad demise. So I would like to pay my homage to this legendary Indian mathematician, Srinivasa Ramanujan, and we begin with the topic today. I hope these slides are visible now. Can someone please confirm that slides are visible?
Yes,
Okay, thank you
yes,
very much. So
yes,
this is the topic today: genesis of zero, an eternal enigma. You are talking about the importance of mathematics in 21st century, and what I would like to suggest and justify in these coming 2 hours that I have, that the whole importance of the modern mathematics and the progress of the modern civilization, uh, European it to begin with, and then all around the world, would never have been possible without this decimal system with zero that is claimed to have originated in India at some long distant past. So that's what we are going to talk about. And it's only befitting to begin with this great saying by J.B. Halstead, that importance of the creation of zero mark can never be exaggerated. This giving to airy nothing, not merely a local habitation and a name and a picture, a symbol, but helpful power is the characteristic of the Hindu race from whence it sprang. No single mathematical creation creation has been more potent for the general on-go of intelligence and power. So that's a great saying. You see, this single mathematic creation that has been more potent for general on-go of intelligence and power. So why it's so important? And what is the relevance of this claim that India invented zero? You know, it is almost known to every educated Indian that it was invented in India. But unfortunately, almost all the cases, the whole knowledge stops there. We don't bother to know, or there is no formal system in our education frame that we may automatically come to know about the relevance of this claim. You see, this what exactly this invention means. Zero was not invented in a chemistry laboratory, like, you know, mix you something with something else and zero evolved. Not at all. Zero was not excavated from under the ground from somewhere. So what exactly this invention mean? And moreover, if it was invented at a certain point of time, what was before that? How could people calculate without zero? And if it was invented in India, what about the other races? There are so many other ancient civilization that has touched at a real height in different aspects. We have Egyptian civilization, Babylonian civilization, Mayan civilization, Chinese civilization, Greek civilization, Inca civilization, Roman civilization, so many ancient civilizations that prospered at different corners of the world. Today, everybody accepts zero. Today, everybody calculates in terms of decimal system. But was it right from the beginning? No, never. So what was their own system of enumeration? How could they calculate? Did they have something like zero? If not, how could they manage? What was wrong with that? Why did they shift to this idea of decimal system with zero? What is the advantage? And if they had some sort of zero, then why that zero is not considered as the predecessor of the modern mathematical zero, Indian zero? So I just like to touch upon all these issues. You know, it's a big, it's like a, you know, endless topic. So many things are to be discussed and known. As you can see from this, you know, what I have been trying to impress upon you, that this history of natural evolution of zero is actually a history of 5,000 years of human civilization across the globe. Everywhere, in every nook and corner of the world, there are different civilizations that popped up at different point of time. They have their different culture, different language, completely different kind of civilization. But all of them share a common idea of counting, enumeration. And this system of enumeration is not the same. If you think of Roman system, the system that we still somehow follow in, you know, writing which class we read in our early boyhood days, still people write class 1, 2, 3 up to class 12 by Roman numerals. And that's how we have some sort of exposure to the idea of Roman numerals. And you see, it is not a place value system. In Roman system, when you write a kind of English V, that stands for 5, and then to the right of it, you draw a line, a small one, and that becomes 5 plus 1 equal to 6. And then one more line, it is 6 plus 1, that's 7. One more line, that is 8. But look at the lack of logic. One further more line will not make it 9. For this V-like thing, which is taken as 5 in Roman numeral, to the left of it, you draw one line, it is 4. But to the left of it, you draw 2 lines, it is not 3. It is not reduced by 2, just like it is increased by 2 if you put 2 such straight lines to the right of it. So that was the clumsy Roman system prevailing in Europe before Renaissance. So it is said that if this Indian enumeration system, the decimal system, the place value dependent system, Roman system is additive in nature, additive and subtractive. It's unlike our place value system. And if this place value system with zero had not reached Europe through the Arabs from India, the present prosperity of science and technology would never have been there. So we'll try to justify all these big, apparently tall claims in the coming few hours that I have. So I just quote from another of beautiful statement made by one professor of Indian Statistical Institute and good friend of mine, Amartya Kumar Datta. In one writing, he writes, India gave the world a priceless gift, the decimal notation. So if you have to understand the actual relevance of zero, you have to understand it in the backdrop of this place value system, decimal system. Unless it's a place value system, you don't require zero. Just like Roman system, you don't have a zero in Roman system, and it's not required. Then what is wrong with that? Why don't we do with that? I will show. Things become very clumsy, very, very lack of logic, and ordinary computation become extremely difficult unless it's a place value system. Larger the number you want to represent, more and more symbols you require. Amartya says, this profound anonymous invention is unsurpassed for sheer brilliance of abstract thought and utility as a practical invention. The decimal notation derives its power from two keystrokes of genius, the concept of place value and the notation of zero as a digit. Zero as a digit. You know, zero has two roles to play in the system of enumeration. When you try to distinguish between 11 and 101 or 1001 in writing, not orally. Orally, when I say 11, when I say 101, when I say 100, I don't require zero orally. But when I write 100, when I write 101, I require the symbol of zero. Unless you have the symbol of zero, you cannot differentiate between 11 and 101 in our decimal system, or for that matter, 1001. So you have to put zero inside. That role of zero is called placeholder. It allows the other numerals to take its own place in this place value system. Zero fills the gap. That is one role of zero. But that's not the true role of zero. The true zero is a number in its own right. When you write 2 minus 2 equal to 0, that zero is the numeral. That zero takes part in arithmetic as powerfully as every other integer. That is the number in its own right. You know, in various different civilizations across the world, at various point of time, different idea of this nothingness to be presented by some symbol. They have their own names. Zero is just an English word. Of course, in India, it was shunya or kho. I'll come to that later on. But in other civilizations like Chinese used to call it Kong. There are separate such names. But those mostly were placeholder zeros. Nowhere except India, this concept of placeholder bloomed into the full, powerful mathematical zero. That's the speciality of Indian zero. But you know, you have see some questions in front of you. What zero is, what zero does, why zero looks like what it looks like. This circularity, this circular symbol with empty interior. Why zero looks like what it looks like. How did zero originate? In which culture did zero originate? How did it get the present name zero? As I told you already, zero is an English word. If it was invented in India at a point of time, exactly when, nobody knows till now. It's still an open question, a very hotly debated one. The exact time frame. There are so many arguments and counter arguments among scholars worldwide. Even among them who consider that this is an Indian invention. But exactly what time, who did this invention, that is not yet decided. Researchers are still on. It's a very much living subject. But one interesting point that I'd like to draw your attention to is how the name zero came into the picture. Zero is an English word. India at that ancient period of time, the language was Sanskrit. The word was shunya. So how is the transformation of shunya into zero happened? That's an engaging story. Why Indian zero is generally recognized as the forefather of our modern mathematical zero? What are the other claims and counterclaims of the origin of zero? Believe me or not, each of these questions that I have framed in front of you, I can talk on that for hours. So many things are there to be known. So many things are there in literature available. Of course, we don't have time for that. It's not required as well. I'll just focus on one or two issues so that in the coming time frame that I have today, I can make some sense of some of these questions, right? As I have pointed out, that these are the ancient civilizations. Each played some part in this story of natural history of zero. Each one is relevant. As you can see, so many important ancient civilizations apart from India. If you want to know really the evolution story of zero, you have to go through all these civilizations and their enumeration system, the lack, the advantage and disadvantage, the idea of half-baked zero-like nothingness in some of these civilizations. And then only you can put Indian zero in the proper perspective in comparison with them. What is the supremacy of this idea? But of course, I don't have time for that. What I have decided today is this, that I will put Greece by the side of India. Mostly I will focus on the idea. Greece is, there is a great, school of scholarship called Eurocentric scholars. They believe, scholarly belief, that Greece is the cradle of modern science. And there is a claim that zero was actually originated in Greece. In contrast with the claim that it was originated in India, there is a very strong international claim from some school of intellectuals that it was actually originated in India. So today, what I propose is to put these two claims side by side so that you can make up your mind at the end of the lecture that which side you would like to take. These are scholarly discourse, right? It doesn't mean that every Indian scholar is in favor of Indian origin of zero, or every European scholar is in favor of Greece. Not at all. There are so many great European scholars who favors India and the origin of zero in India, for that matter, and vice versa. There are many Indian scholars who believe that no, it was in Greece actually. So these are scholarly discourse, historical discourse. I'll just try to put forward in some pictorial manner with some references and stories and pictures that will allow you to make up your mind. But of course, I would like to tell you at the beginning that this is a very, very incomplete story that is going to be told today, because so many other important civilizations are there, so many other stakeholders, particularly modern day. There is another claim from China as well, that there was the origin of zero in China before India. But of course, these are called minority views, right? Mostly the most important contenders are Greece and India. So I have an intention to put them side by side today and discuss. But before that, let me, in a lighter note, begin this lecture with this particular slide. You see, this is a bust of Aryabhata in front of Pune, Ayuka, the center for astronomy. This exactly how these people look like. But there's a popular joke that runs in social media, the Facebook, and I have been told about this joke by my daughter that Baba, since you are so very interested about zero, you may like it. So this is something very hilarious that I find, and very unfortunate as well. I'll explain why I think it to be unfortunate. The story goes this way. One day Aryabhata asked his wife, "Will you allow me to spend the night out with my friends?" And the wife says, "According to your calculation, what is the probability of my giving consent to this?" See, you are a great mathematician, so why don't you calculate yourself? What is the probability of my saying yes to this proposal? And it is then Aryabhata invented zero. I mean, this is completely hilarious. People laugh at it. Everywhere where I tell this joke, everybody start laughing. But see, I find it very unfortunate because this is a misinformation. We Indians, it's so unfortunate that history. We always look at the foreigners, particularly the Britishers, the colonizers. Whatever they told us as our history, we blindly accept that. I know many books of India, they profess this wrong statement that Aryabhata invented zero. First of all, his name is wrongly spelled, Aryabhatta. He is not a Vatta. Vatta and Vata are two different clans. Aryavata he was. His book is Aryavatiya, not Vattiya. And he never invented zero. He just used it. in his famous book Aryabhatiya, he used it. He did many fantastic mathematics using the concept of zero. The calculation of finding square roots and cube roots of numbers, calculation for pi, many fantastic things. But I will show you, if time permits, right today, that at least 700 years before Aryabhata, in the Pingala Chanda Sutra, a book of Sanskrit prosody, in the 2nd century BC, mind you, Aryabhata is some 490 AD, so it is at least 700 years earlier. In Pingala Chanda Sutra, we have concrete reference to the numeral zero. In 8th chapter, in 2 sutras of Vedic prosody, the sutras by name are Rupe Shunyam and Di Shunne. I'll come to that in more details at a later point of time. So Aryabhata didn't invent zero, but unfortunately that is being professed in most of the books. I have seen even, a national level quiz in television, where the quizmaster asks who invented zero, and the students, if they answer Aryabhata, they are given full marks. So unfortunate that we don't know our own history. Aryabhata is only in 5th, 6th century. It was much earlier that zero as a functional mathematical number was already known. And I'm not talking about the philosophy of zero. The philosophical zero, the concept of nothingness, that is even some more 1,000 years back in India. You can find it in the Vedas, as I will show you today. This is one of the great, discovery of Aryabhata. In his book that I have already pointed out, 499 AD, he gave this approximation. It's a fantastic approximation of pi. Chaturadhikang satamasta gunang dvasvashtis tatha sahasranam ojutadaya vishkamvasya ashanna britta parinaha. What does it mean? It's very simple. Whether you know Sanskrit or not, it doesn't matter much. See, I myself I am not a Sanskritist by any standard. But we being Indians, our languages are all derivative of Sanskrit, most of the languages. So we can, if you want to follow Sanskrit, it's not that difficult. Chaturadhikam shatam. So sata is 100, Chaturadhika is 100 plus 4. Ashtagunam, so multiplied by 8, as I have done in the last line, you can see that. Dvashashtis tatha sahasranam. Shashti is 60, Dvashashti is 62. And then Sahasranam, so it's 62,000 that is to be added. And this number, what does it stand for? Now, this is what Aryabhata says. Ojutadaya Viskamva. So, Ojuta is 10,000. Ojutadaya 20,000. Vishkamva is the diameter of a circle. So, Ojutadaya Vishkamva. So, it's a circle having diameter 20,000 unit. If you divide by that number, then what you get is Ashanno Britta Parinaha. Britta is circle, Parinaha is the circumference. So this is a formula for the circumference of the circle. And it says that if you divide that number by 20,000, what you get is the Ashanno Britta Parinaha. Now, my friend, you look at the numerator and the denominator. What does it tell? In the modern notation, you know that the circumference is 2 pi r. And if you divide it by Vishkamva, 2r, then what you are supposed to get? The value of pi. And look at this Aryabhatian calculation. If you calculate this value, it turns out to be 3.1416. That's Aryabhata. That's the genius of Aryabhata. And not only just this value. Don't think just this value is important. Look at that red colored part. Man knew at that primitive time that this is not an exact value. Pi cannot be exactly numerically evaluated in decimal systems. It's an approximate value. Ashanna. That's the genius of these people. Zero was already there, very much there. Aryabhata only told that from one place to other in the decimal place value system, sthanat sthanam dasagunam swat, eka dasa satancha, etc. He's enumerated the places. Kottar budancha brindam, 10 to the power 9 is brinda. Koti arbuda brinda. From just 1 to brinda, he just enunciated one by one, and then he says sthanat sthanam dasagunam sat. From one place to other, you have to multiply it by 10. So that's enunciation of this. Doesn't mean he's inventing it. This was there, very much there, from thousands of years. Anyway, let me get to the idea of this number system and the relevance of zero there. There's another great saying by Pierre Simon de Laplace. Any student of physics or physical science is conversant of Laplace. Now, this gentleman says the ingenious method of expressing every possible number using a set of 10 symbols. That's important. Only 10 symbols. You see, when you are using Roman kind of things, that was also prevalent in other civilizations like Egypt, additive number system. There is no end of symbols. You cannot say that all numbers can be expressed by this many finite number of symbols. Larger the number is, more and more symbol had to be invented. There is no end to it. But here is a method. Here is a method that professes that by using only 10 symbols, you can write any number, however large. And here, this is Pierre Simon de Laplace. He is telling that each symbol having a place value and an absolute value, it emerged in India. So what is this place value and absolute value? Very simple thing. Say I talk about the number 111, 111. See, all the digits I use are 1. So this 1, whose absolute value is 1. But in this particular number 111, the first one in the right, it stands for 1. But the second one, the one in the middle, it stands for 10. That's its place value. It is 1 into the place. The place is the tens place. So instead of 111, had it been 1, 2, 3, the units 3, 3 into 1, 3. Its value is 3 because it's in the place of 1. But the 2, 1, 2, 3, the second 2, this 2 is playing 2 roles. 1, 2 as a number itself, it is 2. But in this particular number, its role is 2 into 10, 20. So that's the place value of 2 in this particular number. So that is the beauty of this place value system, that you are using only 10 symbols, 1 to 9 and 0. And you can write any number you feel like, however large. The idea seems so simple nowadays that its significance is no longer appreciated. The importance of this invention is more readily appreciated when one considers that it was beyond the two greatest men of antiquity, Archimedes and Apollonius. Believe it or not, this idea of 0 was not known to Greece. This idea of place value system, they never used. Their system was also additive, as I'll come to show you. Another great saying by a great fantastic book, The Wonder That Was India. Most of the great discoveries and inventions of which Europe is so proud would have been impossible without a developed system of mathematics. And this in turn would have been impossible if Europe had been shackled by the unwieldy system of Roman numerals. Look at the language. Europe had been shackled by the unwieldy system of Roman numerals. The unknown man, and yes, unknown man, we still don't know who exactly invented this idea and exactly when. There are plenty of guesses, academic guesses, with supportive documents, arguments, but exactly it is not pinned down till date. The unknown man who devised this new system was, from the world's point of view, after the Buddha, the most important son of India. His achievements, though easily taken for granted, was the work of an analytic mind of first order. So, see, these people are not Indian people. They are great historians, scientists, and this is what they tell about this Indian origin. And why this clumsy Roman multiplication? Why is this called clumsy? The shackles of unwieldy Roman numerals. Look at this. This tells you the story. This is a simple multiplication of 58 into 25. Our class 2 students simply do it. And it can be done in these 2 lines, as you can see in the top left part of my slide. But what about the corresponding multiplication in Roman? You see it in the right. And you see how clumsy it is. So many numerals, so many symbols, so many things. The whole interpretation is written at the lower part of the slide. So many things you have to understand, and then you have to add all of them, and you need to know all these symbols, and then only you can conclude that the product is 1450. So if this is such a simple multiplication is so complicated, then you can think, what will be the situation for division? What will be the situation for larger mathematical calculation? And now you see the relevance of the claim by Basham. Most of the great discoveries and inventions of which Europe is so proud would have been impossible without a developed system of mathematics. And this in turn would have been impossible in Roman numerals. That's how, when this decimal system with 0 from India through the Arabs, it reached Europe. They accepted it, but not overnight. It was a story of 500 years struggle. 500 years, because church was against this. Church thought that all this came from Arabs, and Arabs are Muslim, and church, as you know, is Christian. And this is the time of the Europe. History says it's the time of crusade. There was a long drawn battle between Muslims and Christians for the dominance. So naturally, church was absolutely anti-Muslim. And this, as they came from the Arabs, they thought it is of Arab origin. For a long period of time, these numerals, this 1 to 9 and 0, it was referred to as Arabic numerals in Europe. Even some 50, 70 years back, these numbers were referred to as Arabic numerals. Now everybody has accepted. Now it is said that these are Hindu Arabic numerals. The origin is India. The word Hindu comes from the Indus River, and that's an Indian origin. And from India, it has traveled to Arab. They have translated into Arabic. These Arabic texts were later translated into Latin, and that's how gradually it percolated. But as I told you, the story of percolation is not that simple. It took about 500 years struggle for this system to take good hold of the whole thing. So that's a very, very engaging story. I'll give you references at the end of my talk if you want to get into the details of this story. There are so many good books that you can refer to, consult. So let me, for the time being, concentrate on this change of name, as I have pointed out already, the etymology of the word shunya in Sanskrit, and how it transferred into the present English word zero. In a very nutshell manner, I'll just pinpoint some of the cornerstones of the whole story. The origin, as you can see, is the suna yat, the past participle of the root she, which means to swell or to grow. And then the linguists say, from semantic extension, it stands for the sense of hollow, the hollow interior. Look at the symbol of zero. The interior is hollow, right? And in the Rigveda Shanghita, this word sunam is found. I have given the reference there. It stands for a sullen state or hollowness. It had been taken to imply lack or want, lack of sun. In that sense, the word sunam is used in Rigveda. The most common parlance, however, in ancient India for zero was kaw. Kaw means sky, cavity, hollow, the empty space, the great void. And that is a very, very important philosophical aspect of this nomenclature, that this kaw stands for zero, which is in a sense representative of nothing. And this nothing was just a negative nothing. This nothing was a kind of positive nothing. It has a subtle nuance of a potential for growth, an womb-like hollow, ready to receive and swell. That is the dichotomy of this, philosophical dichotomy of this nomenclature. That is why the synonyms of kaw in ancient India was akasha, the vast expanse of the sky, the limitlessness, infinitude, ambara, gagana, antariksha, and even purna. Yes, purna was equivalent to shunya. They are just two equivalent words in ancient Indian philosophical perspective. God is considered as both shunya and purnya simultaneously. Anoronian mahato mahyan, the one who is minuter than the minutest and simultaneously larger than the largest. That is the Indian philosophy. So that is the speciality of Indian context, philosophical backbone of this idea of mathematical zero. But if you go to the grammars, dictionaries, like this Sanskrit lexicon, Amar Kosha by Amar Singha in 5th century, if you go for the grammatical meaning of the word sunam, then you see Amar Singha says shunyam to bashikam, tuchho riktake. So it stands for bashikam, which means void or empty. Tuchho, trifling. Riktaka means emptied or. It is only the negative sense that is being treated in the grammatical meaning or the dictionary meaning. So what happened when this traveled to the Arabs in the court of Abbasid Caliph Al-Mansur in 8th century at Baghdad? One gentleman, Al-Fazari, translated this Brahmasputa Siddhanta, this is a fantastic book of Brahmagupta. This Brahmagupta's book was translated in the court of Al-Mansur. Its name was Jiz al-Sindh Hind. The word Hind refers that this came from India. Jiz al Sindh Hind. And at a later point of time, in the court of Khalif al Mamun, there was a particular group of people assembled together. It was called the Bayat al Hikmah, the House of Wisdom, much like the Navaratna congregation in the Vikramaditya's court in India. It was in Baghdad, Bayat al Hikmah, and Khwarizmi, who also worked on Brahmasputa Siddhanta, Brahmagupta's book, and have written something new, original along with it. Al-Jabar wal Muqabala, the word from which the present English word algebra came. The book written by this gentleman, Al-Khwarizmi. There he translated, these people came across the idea of Indian place value system along with zero. And in Arabic, they translated this. Zero was translated by Al-Khwarizmi as Sifra. Sifra. You see, Sifra, the Arabic root of the word is SFR. And this SFR, it comes from the word Safira. It means it was empty. Anything, almost every word that comes out of this root in Arabic, they are related to emptiness. Asfara, Safir, Safra, and so on. So you see, they have actually an idea. They got the dictionary idea of the meaning of the word zero, shunya. The philosophical dichotomy that it also stands for everything was gone missing. So from that point of time, shunya or ka has been translated with a connotation of nothingness, that it represents nothing. It's a mathematical symbol for nothing. And later on, this name, Sifra, when it was Latinized by oral pronunciation, it got changed over years. It's a long process of, again, 400-500 years that I'm talking about in one single line. The name gradually changed to Saifra, Sifra, Zaifra, Zifra in various different texts by various different authors. Then we get one major player in this story. Fibonacci is the son of Boccaccio the trader, Italian trader. He used to trade with the Moorish Arabs living in the eastern coast of Africa. He was in Italy. He used to go to the eastern coast of Africa with his young boy, Leonardo. This is his nickname of Leonardo of Pisa. Pisa is in Italy. So Leonardo of Pisa, nicknamed as Fibonacci. With his father, young Fibonacci used to go to these Arabic markets, and there from the Arabic traders, young Fibonacci came to know about this Indian system, the system with 10 symbols by which you can write as large a number as you please. Remember, that is the time when Europe is using only Roman numerals, and through Arabs, they are coming into the contact through the trade, and thereby they are trying to learn this system. When this gentleman Fibonacci became a mathematician at a later period of his life, to early 13th century, he wrote the book Liber Abaci, Book of Numbers, and there he gave the name Zephyram to this concept of zero. Zephyram. So the Zifra now changed into Zephyram. If you go for the Latin word-to-word meaning of Zephyram, then it means light westerly breeze. As light, so light that you can almost don't feel it. So you see the idea of nothingness, almost nothingness in the naming, Zephyram. And this Zephyram later became in Italian, local Italian language, it's converted to Zefiro. And from that gradually changed into zero. That's in French. Venetian zero, French zero changed into English zero or Spanish cero. Not only this word, other words related with this development are this cifra in Spanish, chiffre, chiffre in German, ziffer in German and chiffre in French. These are all words related to the idea of number and digit. They are all derived out of this particular development. Not only that, you have another English word, cipher, something that you have to do in a clandestine manner. You cannot do it in open. Zero was called cipher. Why? Because at a point of time, as I pointed out already, church banned these numeral systems, this decimal system along with zero. There's a ban of church, and if you go against church at that point of time, you could have been burnt alive in stake, as there is in history, of Giordano Bruno, burnt alive because he professed against the teaching of church. So that was the situation when Italian traders, the traders of Venice, they used to calculate using this, but not in public. Not in public. That's how the word came, cipher. Something that you do secretly. It was done secretly because they saw the advantage, tremendous calculative advantage of this new enumeration system compared to the clumsy Roman system. But they couldn't do it in public. That has to be done secretly. That's how the symbol 0 got the name cipher. Right? These are all fantastic story. And as I told you, things can be told, I mean, for hours further. That from these Arabs, when this is reaching Europe, what is the first reference in European land that we get about this Indian origin of this system? This is a gentleman, a Syrian monk in 662 AD, Severus Sebokht. Is the earliest reference of Hindu numerals that we see in European land. He says in his writing that I shall not now speak of the knowledge of Hindus, of their method of calculation, which no word can praise strongly enough. I mean the system using 9 symbols. Be very careful, my friends. This is a very interesting observation. Symbol, he's talking about the symbols, numeral symbols, but it's a system using 9 symbols. The 10th one has gone missing. 1 to 9 is fine. But the absence that is to be marked by some other, they are not yet ready to understand that that symbol is also a numeral in its own right. They are still considering that to be something separate in a different footing. This is just a placeholder, perhaps. That was the early approach of Europe. Years 976, you see the Codex Vigilanus by Monk Vigilan in Spain. This is oldest among all European existing written documents on numbers. And it shows the 9 Hindu Arabic numerals, but no 0. As you can see here, this is the exact writing, the photograph of the Codex Vigilanus, which is now kept at El Escorial in Spain, where I visited in 2006 during the ICM held in Madrid. So there you see that these are 1, 2, 3, 4 from right to left. And this is what is written over there. It's translated. The Indians have an extremely subtle intelligence. The best proof of this is the 9 symbols with which they represent each number, no matter however large. See, they still miss the point that with just 9 symbols, you cannot do it. You need a 10th one as well, and it is there, 0. But they are not ready to accept 0 in the same footing as the other 9 symbols. And then Liberace have this Fibonacci, Leonardo Pisa writes with these 9 numerals, still 9 you see, with these 9 numerals and with this sign 0. See, they are in different footing. Those 9s are numerals, and this is a sign called Zephyram in Arab. One writes all the number one wishes. Even few years late, another gentleman, Maximus Planudes, he writes, there are only 9 figures. A sign known as Zifra can be added to this. Look at the hesitant approach in accepting the relevance of 0 in the system, which according to the Indians means nothing. 50 years back, it was in Arab, referred to Arab. Now in 1252, a gentleman refers that according to Indians, it means nothing. So I'm not taking any stake. Indians call it nothing. Don't blame me. Indians call it nothing. I'm just mentioning it. That's the approach. The 9 figures themselves are Indian, and the Zifra is written thus. That's the symbol there in 1252. And would you believe that you may find in a text in Europe? It is a book by Philippi Calendari. Its name is De Arithmetica Opusculum, written in the Latin, and this is in 1492. The first ever written 0 in European soil, 1492. You believe it or not? Okay, let me now concentrate on Greece. I told you that today I'd just like to place these 2 claims and counterclaims of Greek origin and Indian origin side by side. So let us see that how these Greek philosophers, these great mathematicians and thinkers, Aristotle, Euclid, Pythagoras, Archimedes, so on and on, so many big names, undoubtedly one of the tremendously developed ancient civilization. What was their numerical system? How could they enumerate? What was their number system? Did they have 0? How could they manage without 0? So to answer that, look at this system of Greece. Every young student of mathematics knows about these alpha, beta, gamma symbols. Interestingly, these were their numerical symbols as well. There were no separate numeral symbol. These same alpha, beta, gamma used to represent numbers as well. So how to differentiate? Within a language, if you write some number, how do you understand whether language is written or the number is written? This is the convention. Look at the last line of this slide. A bar on top of a certain part of these numerals, of these alphabet symbols represent that this is a number. And how this number is to be read? Well, as such, there were 24 classical alphabets from alpha to omega, and they have added 3 more for this enumeration purpose. 3 more particular archaic forms called digamma. I have just marked them by red: digamma, koppa, and sampi. And they made this chart of 9 numerals in units place, 9 in tens, 9 in hundreds. That means when you look at this example, the example in the last line of the slide. When you look at this sigma, mu, alpha, and a bar on top, bar tells you that it's a number. What kind of number? Mind you, it is additive. So you have just add the value of one symbol with the other. So alpha is in the units place, and you look at the chart, units place alpha stands for 1. So mu is there in the chart in the second column, in the tens column, and mu stands for 4. That means 4 in the tens column is 40. So what you do is, this is 40 plus 1 is 41. This is 40 plus 1, that is 41. And then you have sigma, and sigma is in the third column. So sigma stands for 2, but in hundreds. So this is 200 plus 40 plus 1. That's an additive system. No need for 0 in such a system. But again, you cannot write large numbers by this. You believe it or not, the largest number they could manage was only 10,000. Myriad, myriori in Greek language. That's the largest number they could think of. Of course, there's a great genius, Archimedes. There's a fantastic problem called the sand reckoner, where Archimedes proposed larger systems. But that was only for Archimedes. That was not popular anywhere. Nobody understood that. I don't have time to get into this great story of the sand reckoner. That's how that particular system that Archimedes professed, actually. You can look at that in other texts or internet, everywhere it is there. But even in the sand reckoner problem, if you delve deep into the idea of Archimedes, you will see that there is no idea of 0. Where he ends on one stage, one tire, the next tire, it begins with that particular number only. Okay, I'm not getting into the details of that. Let me just tell you, let me just share with you this much, that there was no 0 in this Greek alphabetic Ionian system. The question is, why the Greek genius, the natural inheritors of Babylonians, could not see the power of place value system with 0? I just tell you one single line about the Babylonians. Babylon, before Greece, Greek civilization derived out of Babylonian civilization, and then it further prospered into the Roman time, Greco-Roman period. So Babylonian civilization was earlier, and from Babylonia there was a contact with Greece. So Greek people knew that there is a system running in Babylonia. That system is a place value system with sexagesimal notation. Our system is decimal today. Decimal means value, place value is 10 and powers of 10. They had sexagesimal, that is, place value was 60. And 60 squared place, and so on. Just like 10, replace 10 by 60, and what you get is a sexagesimal system. That was a system prevalent in Babylonia or Sumeria, right? And there was a symbol used as a sign of separation, the role of placeholder of 0. As you can see in this slide, that's the sign of separation here. That's the first ever known written symbol for 0, which was used as a placeholder and not as a number in its own right. Never ever in the Babylonian clay tablets it has been found that this is used in the sense of x minus x equal to 0 or 2 minus 2 equal to 0. This symbol was used to fill up the gap between numbers, and that too only after 400 BC. Before that, for thousands years, when they had their own system, working system of sexagesimal place value system, you know what they did to represent this gap? They just kept the gap open. That was very, very clumsy, and that was very, very confusing for everybody who at a later point of time looked, don't know 0, and in the decimal system you would like to write 101. So what do? You write 1, keep a gap, and then you write another one. Okay, fine with you, because you know that there is one gap for one nothingness, one absence of symbol. But somebody else came to see your writing, and what he or she sees, one, there is a gap and there is another one. Is there any way that this person can understand that what is this gap standing for? How many zeros? Whether you wanted to write 101 or 100001? That was the confusion. More confusion was with the number having 0 to the right. Like you write 1 and you leave it there. Place a gap to the right of it. How many zeros? Do you mean to say it is 10? Or do you mean to say it is 100 or even a crore? That was the confusion. So Babylonian mathematics suffered from this confusion for thousands of years. And then only at a point of time around 400 BC, some gentleman, some person in their civilization who was ahead in intellectual spirit than others, decided that we need to have a symbol for this sign of separation. And that you can see. And it was used in the context of placeholder purpose only. It was never considered as a number in its own right. But there was a sexagesimal system plying in Babylon. The question that I asked here is this: why the Greek genius, the natural inheritors of Babylonian, could not see the power of place value system with 0? Why did they got stuck with this, poor system of alphabetic numerals where they can write only 10,000 as the largest number? The answer to this is Aristotelianism. Aristotle in 340 BC was a great thinker, a philosopher, who preached that nature hates vacuum. There is no vacuum in the nature. And if there is no vacuum, nothingness, they were against this nothingness. There is no 0, no infinity in their system. They say it considered as a number. They were aware of the concept of Babylonian placeholder 0, but they thoughtfully rejected this concept. Why? Because of their fascination with geometry. What is this fascination of geometry? I'll explain shortly to you. That every number for them was a shape. There's a number-shape duality. Further, they propose this kind of philosophical conundrums, philosophical questions. If 0 stands for nothing, how can nothing be represented by something? What shape can nothing have? Because if 0 is a number, 0 need to have a shape. But their idea of shape, the shape of triangle, the shape of rectangle, the shape of squares, all these geometric shapes that they could identify with different numbers, pentagons, hexagons, and so on and on. They were very strong in geometry. In fact, geometry was thought of something essential, absolutely essential to become learned man. Geometry and logic, these are the two basic pillars of Greek society. Logic for philosophy and geometry for understanding of nature. And numbers were understood as geometric shapes. I'll show you how. There is another point, that 0 messed up the neat Pythagorean doctrine of ratio and harmonics. So I'll just dwell upon this. I'll let you know step by step. So the point is, with this kind of restrictions, these great philosophers, these great thinkers, they stood the way of 0. They never accepted 0 as a number. They went against the mathematicians who proposed that possibly this will be better if I use it. But the society was driven by these great philosophers and thinkers. Mathematicians were actually a kind of, less important person. So the philosophers, when they went against the idea of 0, it never prospered in Greek civilization. It is complete contrast with ancient Indian civilization, as I will show you at a later point of time. So then, this is the idea of geometry. This is the Plato's Academy. Surely you have heard of the great thinker, philosopher. Entrance gate, it was written in Greek, and that you translate in English, it turns out to be this: let no one ignorant of geometry enter. That was the relevance. That was the place of geometry at that point of time. And this is their idea of number-shape duality. Every number should have a shape. Like you see, a number is triangular. If you can have some pebbles or beads and arrange a sort of triangle using those many beads, then that number is triangular. Like 1 is triangular in a sense of, this is a sort of, a spatial case, a redundant case. But you see 3, 6, 10, the shape of triangle comes out. Just like that, 4, 9, 16. the square numbers, the pentagonal numbers, 5, 12, 22, and on. This is not end. There's a whole series of that. Hexagonal numbers, 6, 15, 28. You can make hexagons with these many bits. That's why so this is how with every number they used to have one or more geometric shapes. There are more center triangular numbers, triangular number, pentagonal number, oblong number, these, that, so many of them. Shape. And that was the question. If zero is nothing, how can you associate a shape with nothing? How can nothing be represented by something? That was a philosophical question. They posed and they could not answer, and they decided that so zero is not to be considered as a number. But there were even deeper reason for that. Pythagoras, another old thinker, Pythagorean doctrine was this: all is number. Every number shape has a hidden meaning, and the most beautiful number shapes are sacred. That was the teaching of the Pythagorean brotherhood. Pythagoras was considered as a kind of demigod. People from different parts of Greece used to come and see him preaching about nature, about universe, and about numbers. This was the doctrine of the Pythagorean brotherhood. This symbol, as you can see, the pentagram was their logo, the symbol. Infinite regression, one within other, one within other. One pentagram within a smaller one, then another smaller one inside, and there is no end to it. There is another important invention that Pythagoras did. Invention of musical scale via monochord. The idea of monochord, it came to Pythagoras when he was playing monochord. This is a string instrument, as you can see, and if you pluck the instrument by putting a bridge at a certain length, the length of the chord is divided, the length of the string is divided, and what you get at a certain ratio only, the harmonics, the octaves, the higher octaves of the sound, the pure music. And if you do it randomly, some of them will be just noise. This is what Pythagoras actually invented while playing this. And one day he understood that this ratio, the division of the total length into certain two parts, make the whole trick work. So that is how he invented ratio, and therefrom came his idea of rational numbers that we call today in English as rational numbers, the numbers of the form P by Q. And their particular ratio was very sacred to them, golden ratio. And that was taken for the latter half of Europe. Every construction, every geometric construction, everything was considered to be, somehow or other linked with the idea of golden ratio. The harmony of the monochord is the harmony of the universe. That was Pythagoras preached. Ratio governed not only music, but also the other types of beauty. If you have seen the picture of human, the most perfect human being drawn by, Leonardo da Vinci, you will find the golden ratio. Look at these construction. There are golden ratios, because this is what they believed, that ratio governed not only music, but also the other types of beauty. And universe, as Pythagoreans preached, universe is like a nutshell of spheres that make music as it moves. Now you can laugh at it. Now you can think it's a mumbo jumbo, but this is the case at that point of time. And this was accepted throughout. The universe is a nutshell of sphere. The central sphere is the earth. It is immobile. This was their geocentric model of the universe. Earth is sitting as the center. Every other planets, they are in a spherical orbit around the earth, and they are moving. And as they move, they make music. Why? Because they are at a distance which can be governed by golden ratio. All these separate concentric sphere, every sphere for one particular planet, and for them, moon, sun, everything were planet, up to Saturn, 7. They could count by their naked eye, they could see Saturn. See, Saturn in an open sky, even a clear sky today, we can nakedly watch, and by our naked eye, we can watch. Just a few days back, perhaps you have heard of this great conjunction by your simple naked eye. So these people were avid astronomers, and the theoretical idea that they professed was this: that Earth is sitting as the center with all the human beings. Because we are creation of God, we are so important. That is why we are at the center. And all these things, they are in corresponding other circular, or rather spherical orbits, and they are rotating around the Earth. And because they rotate, we see in the sky that they, at a point of time, we can see, and they set at another point of time, because they are rotating in spherical orbits. That is their idea. That was the Pythagorean idea, right? And with this Pythagorean idea of ratio, zero messed it up. because Pythagoras immediately understood that you cannot take ratio with 0. What is 2:0? In modern day notation, you immediately understand 2:0 calls for 2 divided by 0, which is impossible to understand. Division by 0 is beyond the scope of mathematics. So immediately they understood that if I accept 0 as a number, this beautiful theory that made Pythagoras demigod will be crushed. So better don't accept 0 as a number. That was their philosophical doctrine. And not only church, this gentleman, as I already told, Aristotle, he was a very powerful man as well, because he was, perhaps you know it, that Aristotle was a home tutor of the great Alexander. So he was a very powerful man. And Aristotle preached, there is no 0. Everything is finite. Nutshell, finite universe, no 0, no infinity. Universe ends at the last orbit of this night blue sky with all these stars over there. Aristotle said that I can give the proof of existence of God, and I don't need any infinity, any void. There is no 0, no infinity. What was the Aristotelian doctrine of existence of God? Okay, it was this. Look at the right hand side picture. Aristotle said that earth is sitting as the center and it is immobile, it is fixed. So how come this lune means the moon, how come the moon in its spherical orbit, we every day see that it rises in one side and sets in the other? So what makes it move? Earth is immobile, or one move. That was his preaching. Think, my friends, the seed of the Newtonian mechanics. Seed, yes, of course, but yes, seed it is. The body that is immobile cannot make the other thing move, Aristotle preached. So how this spherical orbit of moon is moving? His answer was this, that it must be moving by the movement of the next spherical orbit where Mercury sits. So Mercury is moving, spherical orbit of Mercury is moving, and as it is moving, it is dragging the inner sphere of moon. That's how this is moving. Every sphere is moving because of the external sphere. That is moving, and that movement drags the inner one and makes it move. That was his idea of physics, metaphysics, you can call. And with this argument, he went from one to other sphere. And then finally, after the 7 such planets are over, he has gone outside that and he said, now this is where God himself resides, beyond this 7 sphere. If you remember, if you know, my friends, ancient British, ancient English scriptures, they consider about the 7th heaven. Have you ever heard of 7th heaven? Why 7th? Why not 9th and 10th or 5th? This is the reason, 7th heaven, where God himself sits. And what he does? The last sphere, God himself is moving, because there is nothing else to move. There is no other further sphere by virtue of which the last one of Saturn is moving. So how come that is moving? Because God himself is sitting there and moving this sphere. That's why God in these ancient scriptures are called primu mobile, the prime mover. The God is called the prime mover. And this is precisely the proof of existence of God as per Aristotle. However hilarious it may seem now, you'd be astonished to know that church at a point of time, at a later period, accepted this, and actually not only just accepted, church declared that questioning Aristotle is tantamount to questioning God's existence. You cannot question Aristotle. Church accepted Aristotle for 2000 years in Europe. Going against Aristotle was equivalent to going against church. You have to accept that this earth is sitting in the center and everything else is moving. And that is the Aristotelian dictum. And with the Alexander's conquest of half of the world, this Aristotelian dictum spread all through Europe and outside Europe. Till 16th century, Europe, by the teaching of church, actually stuck to this kind of thing. Everybody, even the scientists who went against and said that no, this is not right, At the center, Earth is not there. At the center, Sun is sitting. It is a heliocentric theory. Right from Copernicus to Galileo, people were tortured and even murdered like Giordano Bruno, burnt alive in stake. That Spanish Inquisition, that was that 500 years of, extremely difficult battle of this conception of decimal system with zero in Europe. And as I told you already, this is the book. This is the page of the book, De Arithmetica Opusculum by Filippi Calandri, 1491 AD in Florence, where you see zero printed first in Europe. And on top, you see a peculiar kind of logic by one Greco-Roman monk who was a very famous person in his time, Boethius. He says, this is the medieval church. That is his idea of church at that point of time. God is omnipotent. There is nothing God cannot do. But God, being ultimate goodness, cannot do evil. Therefore, evil is nothing. And nothing is represented by zero. So zero is evil. Zero is satanic. That was the idea of church. That is how church was so strongly against this idea of zero and the related decimal system. That these are all satanic. These are all evil. And then this is a long story of struggle. I'm not getting into the details of that. At a point of time, there was, confrontation within church itself. That's called the Reformation movement by Martin Luther. And then the command of church was assumed by the King Henry VIII. And then came Copernicus, Nicholas Copernicus. Actually, this famous book, De Revolutionibus, he actually dedicated the book to Pope Paul III so that he is somehow be saved from the anger of the Pope. But that didn't save him. When Copernicus was in deathbed, church banned this book, hailed the Ptolemaic theory of epicycles. Ptolemy was a Greek astronomer who actually held high this idea of Aristotle, the observed universe. Whatever you see, he has proposed a kind of theory of epicycles to explain the direct and retrograde motion of the planets that we see in by our naked eye. Church held that theory up and said that Copernicus, this De Revolutionibus, is a banned book. And not only that particular book, they have actually issued an index of forbidden books, a long list in which this particular book by Copernicus listed. But then still, scientists, they again and again over years talked about the correct model of universe. And there you see in 1600, Giordano Bruno, Galileo Galilei cautioned by church that you should not preach the heliocentric theory. But then Kepler came, he refined the heliocentric theory. He said what was wrong with Copernicus. Copernicus talked about the circular orbits. Kepler made them elliptic, and things become much more exact, much more correct with observational details. Then came René Descartes. Descartes put forward the coordinate system. The coordinate system with zero at the origin, 0, 0. If you put this zero at the origin, Descartes saw that the geometry of the Greeks and the algebra of the Arabs, they are just two sides of the same coin. Every geometric figure, like a circle, a parabola, a hyperbola, a ellipse, they have an algebraic representation called equation, the science that is now taught at 11, 12 level under the name of coordinate geometry. But this is only possible when you accept zero at the center stage, the x and y axis where they meet. That point should be considered as zero, and only then you can think of an equation like x square plus y square equal to r square, representing a circle with zero as origin and r unit as radius. So there is nothing called geometry as a Greek science, the same coin. And how they are put in hand to hand? Accepting zero as a number. That's coordinatization of geometry. That's the first step of algebraization of geometry. But then still 16 more years passed. Galileo confined to house arrest. Church tortured him, asked him that you publicly declare that what I preached was wrong. Earth is not moving. Earth is at the center. But then within few more years, one of the disciples of Galileo, Torricelli, on the Mercury tube, actually created a vacuum that was nailed, the final nail on the theory of Aristotle that nature hates vacuum. There cannot be any vacuum. There cannot be any nothing. There cannot be absolutely zero. Torricelli for the first time on mercury tube. That's an experiment. In the class 8, 9 books of physical science, students are taught about the Torricelli mercury tube experiment, where you can see in front of you that a perfect vacuum is being created. That vacuum was experimented with many other liquids than mercury and many other different heights by Blaise Pascal, and it was accepted. That's how it's a long struggle from 1277 to 1647, almost 500 years, that at a point of time church had to back out this decimal system along with zero. To come to India, that was the story of Europe. That was the story of Europe, the legacy of Greco-Roman legacy. What was the story of India? See, one most unfortunate part of the Indian history at that point of time was that it was all orally transmitted. There is no written records of anything. It was Shruti, the period of Vedic literature. And even that is hotly debated, that exactly what period is it? How far back in history is this particular period of Vedas? There are so many different claims and counterclaims. I'll go by some most rational, I'm not going by minority views that claim that Vedas was some 17,000 years back. So I am going by the majority kind of view. Of course, these are not absolutely decided, but these are the majority thinkers or scholars. That's the way they think. First of all, one must understand that when we talk about ancient India and its, Indian mathematics, Indian science, this is not the present landmass of, international borders of present day India. This India is referred to as the whole Indian subcontinent, right on to the west side of the landmass, to the Burma, Rangoon, and this this Angkor Wat, this Java, Borneo, Sumatra, and all this right hand side, all this landmass is referred as India in antiquity. So when we say that something was there ancient India, I have to refer to this entire landmass, not just the current day India. And this is the sloka from Vedas that shows the spirit of this Indian civilization. Anavadra kratavuyantu vishyataha. Let noble thought come from all directions. This is one of the ICM posters in 2010. ICM is the International Congress of Mathematicians that's held 4 yearly. This is only once till date has been held in India, in Hyderabad in 2010. I was fortunate to be there as a part of the Indian delegation. This was one of the formal poster there, telling the story of Indian philosophy, that let noble thought come from all the direction. We are open to everything. Anything that is logical, we are ready to accept that. And then, is the Vedic civilization the most ancient Indian civilization? Nowadays, by excavation, we come to know about even earlier civilizations, but about them, very little is known. Mehergarh Neolithic artifacts, this is 7000 BCE. Some artifacts, it is now called Greater Harappan civilization. These are Kalibangan, Lothal, and so many other places. Now these artifacts are being found, their own systems are being developed, are being tried to understand. Unfortunately, these Harappan seals, this 2600 BCE, these seals are yet to be deciphered. See, the pictures of some animals possibly are there, which you can easily recognize. But what about the other symbols? Are they some language? Are they just decorations? Reasons are there to believe, the scholars say, that these are possibly some language, but unfortunately yet to be deciphered. See, these ancient languages like hieroglyphics in Egypt has been deciphered. Mayan glyphs have been deciphered. The Babylonian clay tablets have been deciphered. But unfortunately, ancient Indian, these Harappan seals are yet to be deciphered. And I just would like to share with you, there is a Bengali lady, very young lady, BHARATA Mukhopadhyay. He is now doing excellent work with this, meaning mechanism of these Indus scripts. His publication in Palgrave Communication. Everyone heard of the famous journal Nature. It is the one wing of Nature. It's called Palgrave Communication, and it was published last year, 9th July 2019. So she is working tremendously. There are other scholars, of course. Many people are working. There are many claims and counterclaims. Nothing established, but this work is on. Once this is known, perhaps the entire Indian history has to be written afresh, new. A civilization some 7,000 to 10,000 years back of Christ was there in this landmass. but we don't know much about them. What we know is about the Vedic civilization. So we'll just we will just stand on that, and whatever we say on ancient Indian mathematics, on ancient Indian civilization, science, it will be on the Vedic civilization. That starts with the Rig Veda, which may be at least, if not earlier, at least 1500 BC, at least, in a very rational approximation, maybe even earlier. So even at that point of time, 1500 years before Jesus Christ, this is a civilization with such lofty philosophical thought. There you see this idea of nothingness prospering everywhere. So civilization, Veda has 6 limbs. These are called Vedangas: Shiksha, Kalpa, Vyakarana, Nirukta, Chanda, and Jyotisha. Jyotisha is the calendrics, the time calculation. And in this Jyotisha is considered as this Ganita is considered as an opera vidya, the earthly knowledge. This opera vidya was hailed to be at the highest echelon of knowledge. This is another poster of ICM 2010 that I am sharing with you. Jatha shikha mayuranang naganang manayo jatha tadvad vedango shastranang ganitang murdhanistitam. Ganit, mathematics, is at the helm, at the top, just like the crest of the peacock, and as the gem on the head of the serpent, it is at the top of all the Vedangas. Ganita Murdhanistitam. That was the spirit, that was the relevance of Ganita in that particular Vedic society. So in that society, if you look at the philosophical backbone of India, this idea of zero in India, from philosophical backbone that is flourished in various different philosophical schools, in Hindu, in school, everywhere you will see, in contrast with what you have saw in the Greek period, in the Greek civilization, here you will see this nothingness. The concept of nothingness is being embraced, is being experimented, is being questioned, examined, closely analyzed by each and every school of thought. Nobody is considering it as evil. Nobody is actually ready to discard the concept of nothingness. It is on the contrary, nothingness is absolutely important in all these philosophical schools. In Ishopanishad, you see Purnamadah Purnamidah Purnat Purnamudichyate Purnasya Purnamadaya Purnameva Vasishtate. So this is a philosophical uttering, absolutely philosophical, nothing mathematical, but it has a seed of mathematical thinking. If you think of this Purna, I have already pointed out that ancient scriptures use this word Purna as a synonym of Shunya. So in philosophical aspect, if you look at the second line, what it tells, Purna, whole, the complete, infinite. It should. If you take away all of it, still what remains is infinite. The same is true for zero as well. From zero, you take away zero, what remains is still zero. That is the philosophical standpoint of these seers. So that is important to understand, that when at certain point of time the mathematicians of the society wanted to have some symbol, some number for this nothingness, the philosophers, the seers, never crossed that path, never stood against them. They were themselves steeped in the idea of nothingness. You look at the Nashadiya Shukta of Rig Veda. Na sadasin na sadasit tadaning nasidraja na boma parayat. The seer is talking about the time of creation, when there was nothing, absolutely nothing, no Sat and no Asat. There is no distinction between Sat and Asat. It's a time when there was no Raja. It's the dust, the world was not there. No Boma, the sky was not there even. Nothing, absolutely nothing. And then he's asking, who you are, who created everything from this nothing? So that's how they were embracing the idea of nothingness. As I already told you, this idea of Kathopanishad, Anaroniyan Mahato Mahyani, minuter than the minutest and larger than the largest, simultaneously. It's a dichotomy, simultaneous existence of both of them. Maitrayana Upanishad says Brahman is Esha Shuddha Shunya Shantaha. That's how they look at Brahman, the God, ultimate, Shunya. You look at the Vedanta philosophy, there you see the idea of void or Maya. Everything is Maya, complete void. The idea of Nyaya system, Nyaya Vaisheshika, the concept of abhava or absence. Look at the idea of Tantra. Look at the idea of Tantra, Nishkala Shiva. And then the Madhyama school of Mahajan Buddhist doctrine of Shunyata, devoidness of Nagarjuna. They say that the complete Shunyata is the same as the Nirvana. And how do we attain it? By stepwise negating. So this is the philosophical backbone of India. In Rigved itself, you find these nomenclatures which tell you that these are decimal in nature. Shapta Shatani Vinshati, Sahasrani Shatadasha. To arrive at a decimal notation from this terminology, one has to simply suppress the place name from a given numerical expression, provided one has an additional 10th numeral as a placeholder to indicate the possible absence of the 9 numerals in certain places. Thus, one can conclude that the structure of Sanskrit numeral system contains the key to the decimal place value system. Look at these large numbers being mentioned in the scriptures. This is the prayer of Medhatithi in Shukla Yajurveda. There you see the utterance of the word Dasa, Sata, Sahasra, Yayuta up to 10 to the power 12. There are so many such expressions. In Lalita Vistara Buddhist work, you find the reference of 10 to the power 241, 421, which is named as Tallakshana. In the Jaina work of Amala Siddhi, you find the reference of 10 to the power 96 as Dasha Ananta. The place value system is referred by a non-mathematical work is Madhyamaka school. He says Shalakshana Dharanad Dharma. This dharma is not religion. Dharma is the property, the lakshana of object or elements or factors. And there he say, how does it change? It change abasthantarataha, due to the change of state. And he puts forward an allegory like a marker in the reckoning, which in the unit position has the value of unit, in the hundredth position the value of 100, thousandth position the value of 1000. Don't you see the formal working rule of place value system? The one line that I draw in the units place is 1. When I draw the line in the hundredths place, it stands for 100. That's place value system. And this is in 1st century CE in a Buddhist work. In the Jaina work of Anujoga Dharashitra, 100 BC, we find a reference to a particular context that if you take the product of 2 to the power 64 and 2 to the power 32, then you get a number which has 29 places. They refer to as sthana, 29 places. Now, if you multiply these two numbers, you get 2 to the power 96. And you can see in front of you in this particular slide. And this number has one particular 0 involved in it. So unless you consider 0 to occupy a sthana, you would not have counted it as a number of 29 sthana. That's it. That shows that even at that point of time, the idea of 0 as at least a placeholder was in vogue in India. In Paninian grammar, there is a book by M.D. Pandit, 0 in Panini. I can't get into the details. These are all very technical things. But there is a concept of lopaha, adarshanam lopaha, vanishing of the middle morpheme. And scholars say that this is a seed where you can see the idea of this placeholder 0, the vanishing of some of the symbols. So I'm not getting into that because we don't have time to get into all these details. This is fairly technical, the grammar of Panini. If you are interested, you can read that book. I have pointed out. There is another work that I have pointed out at the beginning of my lecture, the Prosody by Pingala. This is the Pingala Chanda Sutra. And if time permits, this itself requires some 2-3 hours. If I just want to talk on Pingala and his beautiful sutras in the 8th chapter of the book, where you see the binary to decimal conversion and decimal to binary conversion, some of the binomial coefficients, Pascal triangles, all these things are attributed to European mathematicians who actually were born only about 1800 years. They are in Pingala Chanda Sutra. If you just read them properly, there are texts. Unfortunately, our formal educational system never professes this thing. You never come to know naturally. But there are texts, there are books. If you want to, you can read them and learn. And there is clear reference to mathematical 0 as shunya in a combinatorial calculation. As I told you, rupe shunyam and vi shunne, the sutras 29 and 30. These two, along with 2 other sutras, vir ardhe and tabat ardhe tad gunitam. If you just club them together and multiply and exactly go through the details, which I'm again afraid I don't have much time for that. So someone can tell me, can someone please guide me? How much time am I, do I have still? What time do I have? Can someone please tell me? Are you with me? What time can I have? Hello?
Yes, sir.
Yes. How much time can I still take?
Sir, you can take 30 minutes more.
Okay, fine. Oh, fine. So then I'll just like to explain this. This is so interesting. This is
Yes,
so
sir.
interesting.
Yes, sir.
Okay, so here you see, I'll just etc., etc. These are pratyayas, as they are called, and there are 6 such pratyayas. Each one is a beautiful mathematics, but I will talk about one particular pratyaya, sankha, and that refers to these 4 sutras. And you see, this is what this text, prosody text, is all about. Prosody is, it's about the meters, Vedic meters. So mathematically, it is like this. In a very nutshell manner, I can tell you that there is this is analyzing the meter. The meter has several places in one line, and these places are to be filled by either laghu or guru shwara. This shwar, this is the idea of laghu and guru. There are discriminations that what kind of utterance is a laghu, what kind of utterance is guru. I am not getting into all those technical things. Mathematically, what it turns out is this, that there are several open empty places, and you have to fill up the places. Like the Gayatri meter, like the Ushnik meter. There are certain number of stanzas that have to be completed with this laghu and guru shwar with some definite pattern, so that you can call it Gayatri, you can call it Ushnik, you can call it something else, Jagati, and so on and on. There are others, and they have a definite pattern of occurrence. The question that being asked here is very mathematical, that there are certain open vacant places, and you have only 2 objects, a laghu shwar or a guru shwar. Laghu or guru, let us call it L and G. How many ways the places can be filled up with this laghu and guru? That was the question asked by Pingala. Mathematical questions, purely mathematical in a sense that he is asking. Right? These are just Chatushpada Sutra, Chatushpada Chanda, and in one pada, a foot, like in Ushnik, there are 7 places. In every foot of the meter, there are 7 places, and it repeats in every 4 lines. That's called Chatushpada Chanda, Abritta Chanda. These are called Matra Abritta Chanda, Chatushpada. So in 1 foot, there are 7 vacant places to be filled in by 2 symbols. Either of them you can repeat. How many ways it can be done? That was the question asked. And there he gives an algorithm, Pingala. This algorithm says that there are 4 sutras: Virardhe, Rupe Shunnam, Di Shunne, and Tabat Ardhe Tadgunitam. I'm trying to explain you. Just be with me. It's not difficult. So this Ushnik, this is a Shamabritta Chatushpada Chanda. In every line, there are 7 vacant places. So write the number of that syllable. The syllable is here this unit of pronunciation, akshara. That's called syllable. It's not syllable in the sense of English. Syllable in the sense of Sanskrit is an akshara, which means a unit of pronunciation, which can either be laghu or guru, light or heavy. So here we are having 7 such vacant places to be filled in by them. The question is how many ways it can be done. Okay, before getting to Pingala, in the modern idea of mathematics, this is a class 11 sum, very simple sum. There are 7 places to be filled in. But do that. Well, every place can be filled in either laghu or guru. So 2 places can be filled in 2 into 2 ways, and so on. 7 places can be filled in 2 to the power 7 ways. That's a very simple sum of class 11 standard, combinatorics, the chapter of combination and permutation. Now look at Pingala. In 2nd century BC, the gentleman is telling you an algorithm that will land ultimately to the answer 2 to the power 7 by virtue of these sutras. If you start with 7, and there is nothing special about 7, you can do it with any number. You start with n, apply this algorithm, you will end up with 2 to the power n. That's the mathematical depth of these results. So I just give an example in terms of 7. How? So that's the rule. First rule is Dhirardhe. What does it tell? So this is very cryptic. These rules, the sutras used to be very, very cryptic, because they are the definition of sutra in Vishnu Dharmottara Purana. It's given that Alpaksharam, the first character of a sutra is this. It has to be compact. Alpaksharam, Ashandigdham, Sharavat Vishyato Mukham, Astobham, Anabaddam cha, Sutrang Sutra Vido Vidhu. These are the characters. Alpaksharam is a very congested, compact. Ashandigdham. You cannot have a question of either this is true, may not be true, may be true. No, that's not a sutra. Shara, universal. It has to be applied everywhere. They cannot have exception. Then it's not a sutra. Astobham. There cannot be any meaningless word in it. It has to be crisp. So there is no way of poetical discourse. You put some extra words in it to have your poetic flourish. That's not allowed. It has to be very crisp. Anabaddam cha, unique. So these are the characters. That's how these are very, very crisp, unless you go through the later part of, commentators. Like you have here so many commentators of Pingala, Halayudha Bhatta, for once. There are many others. Jadav Prakash Bhashya, and many, many more. I'm not getting into that. So with these commentators, you get the meaning of them. And then this is the meaning that I'm putting in front of you. The first one is the or they. What does it tell? That if you can halve this number, if you can divide this number by 2, the number you begin with, if you can divide the number by 2, then in a separate column, you write the number 2. Or if you can't divide it by 2, so see, the number you start with, either it's an even number or it's an odd number. It's an integer, right? Either even or odd. If it's even, you can divide it by 2. And in that case, you divide and write a 2 in the separate column. And if you cannot divide, then what do you do? That's the second sutra. Rupe shunyam. Rupa stands for 1. That's a bhuta shankha. Rupe shunyam. So when you can't divide by 2, you subtract rupe. That's rupam aponayet. So you take away 1 from it and then divide by 2. And in that case, you write a 0 in that separate column. So these are your kind of flags that will tell you that which step you could divide by 2, which step you have to subtract 1 and divide by 2. So that are the steps you are supposed to take. To start with 7, for example. So 7 cannot be halved. So you reduce it by 1, make it 6. And then you write a 0 because you are reducing by 1. Write a 0 to the right of it. And then divide it by 2, no problem. You get 3. Now 3 can be, see, 6 has been halved. Right? So here 6 halved, you get 3 and you write 2 because it has been halved. You write 2 in that separate column. Now again 3 cannot be halved. So you subtract 1. You get 2 and then write 0 in that column. Then 2 can be halved. Okay, do it. That is 1 you get. And because it can be halved, you write 2 in the separate column, the column of B that you can see in front of you. Be halved. So you take away 1 and it becomes 0. It stops here. You see, the mathematical operation of 0 is involved. That from 1, when you take away 1, it becomes 0 and it stops. You cannot proceed further. Then go to the third sutra. Third sutra now, in the opposite direction, it says, Vi shunne. What you are now supposed to do? Here, you go in the reverse direction. Start with 1. Why you start with 1? Because you cannot multiply a 0 with any number. That will not give you any number. See, the idea is pretty clear. That 0 cannot be multiplied with any other number. It will not give you anything else than 0. You cannot progress further. So whatever you end, wherever you end, see, the whole process, whatever number you begin with, number of steps will be different, but it will end at 0. It is bound to end at 0 by this system. And when it ends, it is bound to begin with 1. And then if at the last step you have 0, wherever you have 0, wherever you see that counter 0, the counters are 2 types, 0 or 2. And these are the 2 rules for them. P shunne, if you see the counter 0, you multiply the number in hand by 2. And if you see the counter 2, tabat ardhe, where you have halved and written 2, tabat ardhe, tad gunitam. If you see the counter 2, multiply the number in hand by itself. These are the rules. So you start in this particular example. So you have to start with 1 because 0 cannot be multiplied by any number to get something new. So you start with 1. That's a compulsion for every number, whatever you begin with. And then here it ends. The last counter was 0. So you multiply by 2. The number in hand is 1. You multiply it by 2. You get 2. Then go to the next step. What is the counter? Remember, you are going from down to up. So second counter, as I am trying to show you here, is 2. So that means you have to multiply the number in hand with itself. So 2 into 2, that's 2 square. Then you go to the next. Well, it happens to be 0. It doesn't mean that every time it has to be like this. It doesn't mean you take some other number, do the exercise yourself, you will see. It doesn't mean that it has to be 20, 20, 20 like that always. In this example, it is like this. So it is 0. That means you multiply by 2. And then in the next step, it is 2. So you have to multiply by itself. So 2 square into 2 by itself. That's the square of that. And then it is a 2. So you multiply by 2 again. And then what you end up with is, you calculate it's 2 to the power 7. That's an algorithm. That's an algorithmic approach towards this combinatorial problem. They're having some n vacant places and having two symbols to fill up the vacant places with repetition. How many ways, how many different ways it can be done? The answer is to the Pingala at that particular stage. Given time, I could have shown you that how Pascal triangle evolves, how binomial coefficients evolves. Pascal triangle comes out of what is known as Meru Prastara. That's also another rule of Pingala. So many beautiful things were there. It's so unfortunate that we Indians are not aware of this legacy. And nowadays it is more unfortunate because this legacy is being somehow smuggled, somehow snatched by politics. That's the most unfortunate part of it, as far as my personal understanding is concerned. This has to be an academic discourse, out and out academic discourse. Person who are at the no must only talk. People who are claiming some tall things, that there was a plastic surgery of this in ancient India, and that's a proof of Ganesha. I don't think they are doing good. They are making more damage than good to this ancient Indian history. This actually make the people who are already skeptic, make them more skeptic. And that was tremendous. No iota of braggadocio is needed. You don't need to say that Dhritarashtra must be having a sort of internet connection. Why talking about such far-fetched, meaningless things that you can't prove? Look at the thing that was there. That was in itself fantastic. Preach them, profess them, let people know what was there in ancient India. Don't do this damage by telling things which are far-fetched, which is your conviction perhaps, but there is no proof for it. Proof, even in history, it's not a proof of science, I understand, but there is a pattern of argument, proof in history as well. Either you provide us with that or talk about what it was there. There is no dearth of thing. So many beautiful things were there in ancient India, in Indian science, in Indian mathematics, that our people are not aware of. These are amazing things that one should come to know. There should be proper organizations that should actually practice, preach, and profess this kind of things among mass, so that people may know that what great civilization India was. Not by telling, that Ravana must be having a Boeing, some airways car, and that's how Sita Maya was taken by that aeroplane. Why should we bother to talk about those things that we can't prove? There are so many fantastic things in ancient India, in science, in every branch of science. Let us concentrate on that. Let us preach that. Anyway, so as you can see, there is one example that I told you. So if you just go to the Indian zero, the reference of zero that we can find in ancient India, the oldest zero reference that we see is in the Gopatha Brahmana. Brahmana, as you know, is one of the ancient most layers of Vedas. Brahmana, Aranyaka, etc., culminating with Upanishad. So Brahmanas are the oldest scriptures, and there in Gopatha Brahmana you see this reference, Chidram Khom Iti Yuktam. So Kho, the name of zero, is being referred to as Chidra, puncture mark. So you see how it perhaps at that point of time used to look like. Make a puncture mark in a paper. Just puncture by your pen. See, how does it look like? Of course, it doesn't look like a square, right? It doesn't look like a rectangle. It looks like a circle. So that's Chidra. So that's of Kho at that particular point. Perhaps not more than that we can say, certainly. There's a reference to Shudra. Skudra as a number in Atharva Veda. Kudra. There's a Parjaike Vashwaha. It's being offered. Offerings were being given in Atharva Veda. And there, before Prathama Vashwaha, it is uttered Kudra Vashwaha. So what is this Kudra that comes before Pratham, before the first? What is this Kudra? So some of the scholars say that this is an apparent reference to the concept of zero at that point of time. There are so many like that. The concept of Bindu, Shunya, or Kho was referred to as Bindu so many times in ancient India. Like there's a text in 270 CE by Spujit Dhaja. The text is called Yavana Jataka. There you have this reference to the number 60 as Shat Bindu Jutani. And within few more lines, the same number referred to as Shat Kha Jutani. So this using Kha for Vindu and referring to the same number tells you that Bindu was another name for Kha. Bindu, the dot mark. The Jaina cosmological text of Loko Vibhaga that you can find in the book of Georges Ifra, Universal History of Numbers. It's English translation of the original French book, Histoire Universelle de Nombre. There, Ifra has shown that there are references to decimal place value. This is a Jaina text, cosmological text, parts of the universe, Loko Vibhaga. And there are Bhuta Shankha, word numerals, and this particular scripture was completed on 25th August 458 CE. That's a Monday. As this Ifra has computed by using computer, finding out the constellations that is referred in this book, the position of the stars in different constellation, and then using computer to back calculate that particular time when that particular constellation occurred in sky. He calculated this in his book and shown that this must have been on 25th August 458 CE. So that is the time when this idea of word numerals along with zero was very much prevalent in India. And you see Aryabhata only come much after that. Don't ever tell me, my friends, that Aryabhata invented zero. Aryabhata uses in his typical way, the way he talked about mathematics in his a typical, different way, not the usual one. Don't think the usual Sanskrit you will find there. There's a typical different pattern that he uses. It's called Katapayadi system. And there he says, Ekam dasacha satancha shahasram ayuta niyute tatha prayutam kottar budancha brindam. Koti or Buda and Brinda. Brinda is 10 to the power 9. Koti 10 to the power 7. So start from Ekam to Brindam. He just enunciating Sthanat Sthanam Dasagunam Swat. And there comes after him Brahmagupta in his Brahma Sputa Siddhanta. This is the person who is, for the first time in our history, we find that the clear enunciation of the arithmetic properties of the number zero. He says, Dhanayar Dhanam, Rinam Rinayor, Dhana Rinayor Antaram, Shamoike Khom. That means Dhana Rashi. Positive numbers, if you add, you get Dhanam. Positive numbers are added to positive. Rinam Rinayor, negative numbers added to negative. Dhana Rinayor Antaram. Positive and negative, if you add, you get the difference, Antaram. And Shamoike. If this Dhana Rina are equal, Shamoike, x minus x, you get Khom. X minus x equal to 0. That's the first ever formal enunciation that we get. Doesn't mean that Brahmagupta invented zero. Brahmagupta enunciated this formally. It was there much earlier. And this is another fantastic example. The Loko Vibhaga example is written over there. Panchabha khalu shunyabha param de shapta chambaram ekam trinicha rupam. So there shunyabha is referred. But more fantastic is the previous example on the top of your sheet, where I'll show you that Purna is referred to the number zero. This is by Vaskaracharya, the great Vaskara II. Writes in his book, Siddhanta Shiromani, Rashaguna Purna Mahishama, Shaka Ripo Shamae Bhavat Mamatpatti. So what is this Rashaguna Purna? These are called Bhuta Shankha. Rasha is 6. Rasha stands for 6 different test buds. It tests 6 different kind of text. Tikta, Kashaya, Ittadi. So these are 6 different Rasha. Guna. Guna stands for 3. 3 Guna. Satya, Raja, Tama. Purna. And this is the Purna that stands for 0 in this example. Rasha, Guna, Purna, Mahi. Mahi is 1. Earth, the world, only 1. And then there is a convention followed throughout ancient Indian texts. Ankanang Vamato Gati. As such, you read from left to right. But Ankanang Vamato Gati, from right to left. Think, still that. Till now, when we frame a number in our place value system, units place, tens place, hundreds place, it's from right to left. Ankanang Vamato Gati. So in that sense, this number is to be read in this way. 6301. But the number is 1036. And that is Shaka Nripa Shamae. That's the some Shaka king time that he is referring to. So you add the Shaka correction to this 78 years. And then what you get is 1114. 1114 AD, Common Era. That is precisely the year of birth of this great mathematician Bhaskaracharya. Bhavat Mamatpatti. That's the time I was born. And not only that, the second stanza says, Rasha Guna Barshena Maya Siddhanta Shiramani Rachito. So now you know what is Rasha, what is Guna, and immediately you understand that he wrote Siddhanta Shiramani. He's telling himself that I wrote it when I was 36 years old. Rasha Guna Barshena. So that's how you see here is a concrete reference to Purna being replaced by zero. As I told you at the beginning, there's a dichotomy. And then this great mathematician talked about infinity as well, in the sense of Ka Hara. Ka in the Hara, Laba and Hara, the numerator and the denominator. So a number divided by zero, he considered it, the division is not to be executed according to Bhaskara. You keep this as a symbol, x by zero, and call it x with it according to him. It's a great thing, and this one gentleman, Avinash Sathe, a present day modern algebraist in one of the American universities, he has written a fantastic paper explaining this idea of Bhaskara, the idea of Kahara, and corresponding mathematics that is there in his book Lilavati and Vijaganita. That itself, if I want to explain, that will take another lecture. So I'm not getting into that. But I'm just telling you that there is an idea of infinity here in the Bhaskara's Kahara. He says, Asmita Bikare Kahare, Nor Ashobapi Pravishtishapi Nisriteshu, Bahushapi Swalla Srishtikale Nante Chute Bhuta Ganeshu Yadvat. Meaning, he's looking at this Kahara and explaining the significance of this number, something divided by zero. He says, this is like the Vishnu or Brahma himself. It's like infinite. There is no change in the Kahara by adding or subtracting quantities. Just like infinity plus any finite number remains infinite. That's what his idea is. There is no change in this Kahara by adding or subtracting quantities, just like the infinite, immutable Vishnu, which is not entering or leaving it at the time of dissolution or creation of the world, respectively. The whole world is created out of this Brahma, and by that the Brahma does not reduce because he is infinite. So this is an allegory telling about this number divided by zero. He says it's such a large number like Brahma that with that you add some finite number, it doesn't change. The way we say in mathematics that infinity added with some number, well, it still remains infinite. An infinite set, you put some element in it, few more elements, it's still infinite. It doesn't increase. From an infinite set, you take some element away. What remains is still an infinite set. Purnat Purna Muduchyate. You see the philosophy, that's not mathematics. That's philosophy, but this is mathematics. And the mathematics originated out of that philosophy. Purnasya Purnamadaya Purnameva Vashishyate. From an infinite set, you take away infinitely many elements. What remains still is an infinite set. I don't preach that that was a mathematical rule written in the Vedas. No, that was philosophy. But that philosophy motivated mathematics at some point of time, motivated mathematicians to think in this way. That's the backbone of ancient Indian mathematics. So you see, so many other things to discuss. I just like to conclude now. I just bring it to the end. There were early writing. One very important, significant fact is that you don't search zero. Don't search for shunya in Vedas. There is no reference to the word, the numeral shunya. This Eka, Di, Tri, Chatura, all these numbers are in Vedas. In Rig Veda, there are almost 3,000 such numbers, the largest one being Navatir Navashahasra. But there is no reference to the number Shunya because this is oral tradition. In oral tradition, you don't require Shunya, not even in the decimal system. See, we use decimal system. Have you ever gone to market and asked for zero butter or zero bread? Go to the market and ask the shopkeeper, give me a zero apple today. No, I say I don't need apple. So in oral tradition, we don't need zero as a number. It's not a counting number. When you say 100, we don't need the number zero. 100 is in itself a nomenclature. It doesn't explicitly require the usage of zero. That's why there is no zero in this ancient Vedas. But the system was there. And that system could never have worked mathematically without the concept of zero. That is the crux of the whole story. So when from zero came? When India started writing, that is about the time of Ashoka, the king Ashoka. Ashokan edicts are the earliest known writing, Nanaghat inscriptions. And that writing was in Brahmi, a little bit Kharosthi. But unfortunately, Brahmi and Kharosthi are not place value systems. The Brahmi numerals are additive. much like the Romans. Much later, further development was needed. That the Nagari Lipi that we see in the Gwalior, there we first see this writing. And in the meantime, there is a written document. There is a written document, that's Bakshali manuscript. In that Bakshali manuscript, you find plenty of written zeros and huge arithmetical calculation. The Bakshali is a place, now it is in Pakistan, some 350 kilometers from Peshawar. There, this manuscript was found, was actually dug up by one illiterate farmer who damaged almost the whole thing. This is a birch bark manuscript. Now this is kept at the Bodleian Library, Oxford. There are 70 such pages. Very, almost impossible to touch them. They are put in, this is the book in the top, you see, this is how it's kept between two mica sheets. Now, actually, they are fragmented in thousands of tiny fragments. Only pictures of them have been taken, and with that picture, mathematicians, the historians of mathematicians, they are working on it. They have worked and found out the treasure of mathematics that is there. The large numbers, as you can see in the right, these large numbers are written, and the mathematics of that is now known exactly, thanks to works of many scholars, including the modern one by Takayo Hayashi. There you see these large numbers along with zero. But this zero, as you can see, the right of my screen, you see, my friends, these zeros are written as bold dots. Remember the name Bindu? That was the initial representation of zero in ancient India. Not the way we write it today. That was much later. Before 9th century, somebody started writing this circle without the interior being filled. Somebody thought that what is the purpose of filling the interior, making it bold? Just write the border, that is good enough. Some smart guy. And then that is accepted everywhere. But initially, zero in India was written as Bindu, the bold dot, and there are plenty of such examples in Bakshali manuscript. Bakshali has been carbon dated, and there are several pages. There are several different time frames. It's hotly debated how this is possible. But there are explanations to it. I don't have time to get into the details. This could have been rewritten by people at a certain point of time, because these were, fragmented. These were, maybe it was getting somehow damaged, and it was replaced by the corresponding family for which this was written. There is a colophon. The colophon, in certain page, it shows that this is written by a Brahmin who identifies himself as the son of Chajaka, king of the calculator, and he writes that I am writing it for the son of Vashishta's son Hashika and his descendant. So it is a kind of, important treasure for a particular family. And the Brahmin might have been just a, scribe of the manuscript, not the original author. The original text might have been much earlier, much older, because the Brahmin used the language as likhitam, not virochitam or kritam. Sanskrit, kritam or virochitam is something you take the onus on you, and when you write likhitam, it is just being copied. So expert says that this text that is available now and that is being carbon dated, the original text must have been much older. This was a copy of that written by some scribe, and that itself, some of the pages, as you can see, are as old as 3rd or 4th century. And right at that time, you see the written zero with decimal system and all deep mathematics with them. Very deep kind of mathematics. Quadratic equations, arithmetic progressions, square root approximation. Exceptional rule for this square root approximation on this Bakshali manuscript. Akrite slishto krityuna seshacheda dishanguna tadbarga dalasang slishta iti shuddhi kritikhaya. Time permits, I could show you that this formula leads to an expression which is exactly what Newton-Raphson method says in numerical analysis that is being taught today. Exactly same, my friend, the Bakshali formula for that. So these are there in India, and we don't know of it. This is the page where these numbers are written, these zeros, so many zeros, these large, huge fractions. This is how they used to write fraction. There was no horizontal line between the two numbers. Numerators, just denominator was written below. And this is how the numbers are being found now by the experts, that what exactly was written and how you can decipher pages and find out exactly what should be there. Some of them has gone missing permanently, of course. And then another stone inscription. This was refound by Amir Exel in 2013. It was lost. Initially, it was there. It was found by a French archaeologist. Then it was lost in the time of Pol Pot regime in Cambodia. Then now it is kept in Angkor Wat Museum. And there also you see this bold dot zero. Can you see that here in the right side? The bold dots here. It's the number 605 is written in the Khmer script. The language is Sanskrit, but the script is Old Khmer. So that's in Cambodia. And there it is written, the Shaka year reached 605 on the 5th day of the waning moon. And this is the 605 Shaka year. So add that 78 Shaka correction. So this is an inscription done in 683. And there you see this bold dot. And then the modern zero, the oldest known inscription, stone inscription, mind you. There are other copper plate inscriptions that are hotly debated about their origin or originality or whether they are doctored or not. But this is the oldest known stone inscription that you can find in the Gwalior fort. If you go to the Gwalior fort ever, then search for this Chaturvuja temple inside the fort. And this is the Chaturvuja temple. In the inner sanctum to the right side of it, in the wall, you will find this inscription, Shila Lipi, by the king Mihir Bhoja, that actually dedicates a landmass of 270 hasta long and some 137 hasta wide for paying floral tribute to the Vishnu. That there will be flowers will be planted in this land and floral tributes will be paid. So that's how this Shilalipi, this inscription from King Mihir Bhoja in 9th century, and this is the oldest known stone inscription of zero in Indian soil. 270. You see that zero over? That's the modern zero, the empty interior. But that's only in 9th century. And then people come forward and say, some Eurocentric scholars, so India started writing, India knew zero only in 9th century. Before that, it was not there. But that's ridiculous. That's absolutely ridiculous. And there are so many other inscriptions. I'm not getting into detail. These are all scholarly debates. There's a great scholar there, Michel Danino. He has pointed out to other inscriptions, some places. There are other works. There is a long list of that. I'm not getting into this. This is the genesis of our present day numeral. It started with that Brahmi numeral and gradual deformation, gradual change that has turned out to be the internationally accepted decimal numerals now. And we end with this enigmatic question: is zero a natural number? That's a question of modern mathematics. I started with the fact that this is the enigma, and this is the last enigma that we have. Zero. You see, natural numbers are numbers like counting numbers, 1, 2, 3, 4, the positive integers. They are called natural number. Usually, in a formal text book of mathematics, zero is not considered as a natural number because zero had to be invented separately at a later point of time. The great saying by Kronecker, God created natural number. Everything else is man's handiwork, and zero is, of course, such a handiwork. But now, great mathematicians are coming forward, including people like Terence Tao, the Fields medalist, and this Roger Penrose. And they are advocating that, okay, it's enough. We can now accept zero in the system of natural number. In fact, Tao has written his book, Analysis, Part 1 and 2, considering zero as a natural number and making necessary change in the rest of the mathematics, the change of Peano's axiom and so on. He says, okay, it's quite a long time that we have set zero aside. Now it is good enough. I can take it as natural and do the necessary changes. See, that's how it changes. Some 50, 70 years back, 1 was considered as a prime number. Now we don't take 1 as a prime number. Some 50 years back, every mathematical text used to say division by zero is equal to infinity. Now we teach in school level that division by zero is undefined. Don't divide by zero. So mathematics changes that way. Don't know within coming 20, 30 years, by the advent of these kind of giants like Terence Tao or Roger Penrose, zero will finally be accepted as a natural number or not. But of course, if my student friends are there at the other side that I can't see, please, right at the moment, don't write zero as a natural number. I don't take the responsibility for you getting zero in the exam. If you write zeros, this is in the process of evolution. So treat it at that way. Don't write that zero is a natural number for the time being. And there's a final unsolved question that too involves zero of the zeta function. That's a high-end mathematics. So I'm not getting into the details, but just as an information tell you that Riemann zeta function, where are its zeros? Zeros of a function is where the function somehow in a broad sense it intersects the x-axis. So where are the zeros of Where are the zeros of this zeta function? That's an unsolved problem. It's called Riemann hypothesis. The hypothesis said that is on the complex plane in the line x equal to half contains all the zeros of zeta function, but this is not yet proved. And this is one of the most difficult and most celebrated unsolved problem of mathematics, which if you can solve, immediately you will get $1 million as a prize. That is a declared prize, and decidedly the best, highest accolade of international mathematics, Fields Prize will be waiting, Fields Medal will be waiting for you. So these are all stories of zero. And allow me to end it with here with some references. If you're interested, you can check these references. There are so many others. There's so many good books, scholarly books, popular level books. There's a beautiful book by Charles Siffy, The Biography of a Dangerous Idea. There's another beautiful book, The Nothing That Is, by Robert Kaplan. Those who are interested in the natural history of zero can consult these kind of books. And there are other technical books, scholarly discourses, and so on and so forth. So many things are still being done. There is a foundation, Zero Origin India. Its head office being in the Netherlands. They are doing fresh research now. International monograph is being written. Researches is being done to pin down the exact origin of zero, exact time frame, exact person, if possible, by some fresh evidence. So you are invited to join. Thank you very much.
Thank you, sir. Thank you for your nice presentation. And is also appreciate that. Sir, there are some questions for you.
Sure.
Sir,
Can I
why
stop?
zero?
Okay.
Okay, sir. Sir,
Okay,
why
sure.
zero
Please.
divided by zero is not equal to zero?
Well, that is pure mathematics. You see, division by zero, if you have to define division by zero, let me tell you this way, that how do you define division? The complete division of a number, A divided by B, when you say it is equal to C, it means B into C has to be equal to A. Division is considered as an opposite operation of multiplication. So now, suppose you are dividing some number x by 0. If you want it to be some C, then it should satisfy that C into 0 is equal to x. But C into 0 is known to be 0 for every possible C. So first of all, x cannot be anything other than 0. Fine. Then you take x as 0. Now you get 0 by 0. Now the question is, what is wrong if I take 0 by 0 is equal to C? The wrong is this, that you can take this key uniquely. An operation as an algebraic thing, if you are a student of abstract algebra, you know operation is a mapping. It has to be single valued. It has to have a unique value. So if you divide 0 by 0, it can be any number whatsoever, because that into 0 is equal to 0 and it is satisfied. So you don't have a unique answer. The lack of this uniqueness is answer prevents us from defining division by 0. That's how we say in the modern field, modern, abstract algebra, where the structures are like rings and fields, etc. Division by 0 is set aside. We don't consider it as a valid mathematical operation. That's it.
Thank you, sir. The next one is from Vikram Kesari Janna, sir.
Yes.
There are means we have.
You can ask questions in
Sir,
Hindi if you feel like, because I can perfectly understand Hindi, though I can't speak good, but I can perfectly understand. You can ask questions in
no,
Hindi as
sir.
well, no problem.
I will. Okay, sir. Sir, his question is that my question is to sir. Please tell me why not the planetarian thinkers and not credited India and its inventor of zero in modern century. What lack we are promoting our ancient critical ideas about zero and many like zeros.
Yeah, that's a very unfortunate part of it, sir. In all the great Indian learning centers, though there's so many great learning centers nowadays in India, and so many good departments. But have you ever seen a great Indology department in India? It's in some corners here and there. Maybe something in Pune. There is a small department in JNU. But is every university? They should have some department of Indology. People, young students should be motivated to know about this, at least the history students. But there is no culture for that. I think this is due to the British legacy, this 200 years of colonialism that we were fed by the British scientists, British mathematicians, British thinkers, British historians, and we, somehow or other decided to follow that course. And as I told you, that's my personal view. You can have a different opinion. That modern days, it is seeing some complete different diktat, and where the politicization of the whole thing is happening. That is equally unfortunate as far as I understand it. It has to be purely academic, purely academic. So there are so many museums in India. Why don't we have a zero museum? Why don't you have a gallery where people should come and see this beautiful genesis of zero? It can be done. Only we need fund. We need fund, and we need patronization. We need people who can manage it, and they should put hand in hand, and their government should support. Unless these big projects you cannot consider unless there is a government support. You can't do it from your own pocket. It's completely beyond possibility. So there should be such approach, that this is the ancient India. It doesn't mean that I'm preaching that you should live in ancient India, you should go back to ancient India. No, absolutely not. We should look forward. But there's nothing wrong if I know what India was. That can be motivating factor for me. That can motivate our young learners. But unfortunately, that is more or less missing in the Indian scenario.
Right, sir. Thank you. Sir, another question from Santosh Patra. Whether zero was invented or discovered by Aryabhat?
No, it is not. As I have already shown, if you have listened to the lecture, before Aryabhata, much before Aryabhata, as I have pointed out, at least, if not anywhere else, at least in Pingala Chanda Sutra, you see this functional zero. You see functional zero. You see zero in writing in this Bakshali manuscript, certainly before Aryabhata. So Aryabhata never invented zero or discovered zero. It was there. It was there in his time. He just used it in his fantastic calculations of square roots and cube roots and all this further mathematics.
Okay, sir. Another question from him. Why there is no provision of giving Nobel Prize in the mathematics?
So there are confronting answer. This Fields Medal that is given by Charles Fields, he didn't decide. He actually Fields Medal, the highest honor of this is given by Charles Fields, whereas this Alfred Nobel, who decided for Nobel Prize, at that point of time he considered it as science. Mathematics at that point of time was not considered as science, and it should not be. In fact, till modern days, till now, I am in favor of not calling it science. Mathematics actually is a language. It is the language in which science speaks. As Galileo said, the nature is a great book, and you cannot read the book unless you know the language in which it is written, and it is written in the language of mathematics. So ancient time, old time, mathematics was considered as a art subject. You can find many ancient books, good books. The authors are having degree MA, not MSc. But nowadays, everything, there is a tendency that you call it science. Even political science is now called science. So everything is science now. That's how Alfred Nobel considered only the science subjects for his prize. So mathematics was not considered. Later on, so many other subjects were, one by one added to the list of Nobel Prize. But mathematics was never, because by that time, Fields Medal came into the picture. Fields Medal. And the Fields Medal is given by one gentleman, Charles Fields, from his own, own earnings. And that is given as the highest international accolade. Nowadays, there is another one called Abel Prize, that for full life achievement. Fields Medal is to be given to a mathematician who is less than 40 years old, and it is given in the ICM that I have already pointed out. Every 4 years, there's an ICM in different parts of the world. Some 4,000 odd mathematicians from all over the world come, and there is a body, IMU, International Mathematical Union. They pick and choose at most 4 young mathematicians for the Fields Medal. Some year they give 4, some year they give 2. It's not guaranteed that you have to give 4. There is another prize which is called Abel Prize, which is also very prestigious now. So that is why perhaps Nobel Committee are never considering mathematics again.
Thank you, sir. Last question from Santosh Patra. Why zero would not be hero?
No, it is hero. At least as far as I am concerned, it's my hero. It's my hero. So had
Yes.
zero not been there, the whole thing, whole mathematics would shatter, right? Whole mathematics will
Right.
shatter. Wherever you don't see zero, and you see the beauty of mathematical zero is this. I consider as a student of mathematics, as a professor, as a teacher of mathematics, I consider zero as a naughty boy of mathematics. This this number does not go by the rule made for others. Nowhere ever in mathematics you will find that zero following the rule made for others. This is a number which is,
Yes.
you see, neither positive nor negative. This is a number which is neither prime nor composite. This is a number which, when added to any other number, does not increase it. If subtracted from some other number, does not decrease it. If you multiply something else, vanishes that. So many oddities, so many peculiarities everywhere, not just zero. Zero-like concepts of mathematics, like null set, a peculiar concept. A set that is devoid of any element. A null vector. You say a vector has a magnitude and a direction in physics. But what is the direction of a null vector? So you have to accept the oddity of the concept of zero is this. That's why I call it a naughty boy. You just cannot say, okay, this is so bad, I just discard it. I don't accept this in my system. Then whole mathematics will crush.
Right.
Whole edifice of the mathematics will crush. You have to accept zero as it is. That's the power and that's the beauty of zero in the whole system.
Yes, sir. Why not? Zero is truly a hero for us. Thank
Yeah.
you, sir, for attending all the
Thank you very
questions.
much.
Now, I would like to invite Mr. Balram Mahapatra, lecturer in mathematics, SBP Mahavidyalaya, to conclude the section by his vote of thanks. Over to you, sir.
Thank you, madam. Good afternoon to all of you. I am honored and lucky to have the opportunity to give a formal vote of thanks for this session. First of all, I would like to thank our esteemed guest, today's speaker, Dr. Parthasarathi Mukhopadhyay, for his enlightening us. I extend my hearty thanks to Dr. Vikram Kesari Jana, Doctor of Director of Parts, for his friendly cooperation to organize this webinar. I would like to express my profound gratitude to our principal, Professor M.R. Acharya sir, for his cooperation in organizing this webinar. I would also like to thank Vishwariti ma'am and Manasi ma'am for their guidance and support. I am happy to express vote of thanks to all the participants, including lecturers, professors, students, civil society members who have made this webinar a grand success by sparing their valuable time with us. Thank you, madam. Thank you.
Thank you, everyone. Thank you, Balram sir, for your vote of thanks. Now we should conclude here, and this is our last section for the national webinar. So, thank you, everyone, for uh, making this 3 days national webinar grand success. Thank you, Parthasarathi sir, again. Now we
Thank you very much.
conclude here.
Thank you.
Thank you. କିଏ ଏଇଟା